Hi everyone, Assalamualaikum. In this video, we will continue with example under integration by trigonometric substitution. Now we look at example 3 under radical with square root of x squared minus a squared, and we take x equals to a sec theta where a is a constant, right? Evaluate integration of square root of 4x squared minus 1 over x dx using trigonometric substitution, right? Right, using trigonometric substitution, first step, we take x equals to half sec theta, right? Why we take x equals to half sec theta? Right, from the formulas under integration by trigonometric substitution, we have three types of radical. The first one, in the form of radical square root of a squared minus x squared. We already discussed in example 1. And then, in example 2, we discussed radical with square root of a squared plus x squared. Right? Now, we continue with example 3. With types of radical in number 3, which is square root of x squared minus a squared, where a is a constant. Yeah? So from here, we take x equals to a sec theta. Right? Now we need to find the value of a. Okay? So when we compare from radical in the given question, square root of 4x squared minus 1, we compare with square root of x squared minus a squared. The coefficient of x squared in the formula equals to 1. But now, we are given in 4x squared minus 1. So, the coefficient of x squared now equals to 4. Okay? So, first, we need to write coefficient of x squared equals to 1. Okay? So, we need to factorize 4. Because coefficient of x squared must 1. So, after we factorize from square root of 4x squared minus 1, it is equals to square root of, we factorize 4, which is coefficient of x squared, because we want to write coefficient of x squared equals to positive 1. And then in bracket is minus, and then 1 over 4. So that when we expand, so we have 4x squared minus 1. We get back the left-hand side function, right? And after that, we can simplify square root of 4. So we have 2 here. And we still have square root of x squared minus, from 1 over 4 here, we can write 1 over 2 bracket squared, because we want to write into the form of a squared, right? And from here, when we compare, now we have coefficient of x squared equals to 1. And our a now equals to half. Alright? So after that, we replace our a into here. So that's why we get this. X equals to half sec theta. Alright? Alright. And then we continue with step 2. Since we have term containing x squared for radical square root of x squared minus a squared, so step 2, we need to find x squared. So from step 1 here, we squaring on both sides, so we get x squared equals to 1 over 4 sec squared theta. Right? Alright, in this case, we don't need to find x cubed because there is no term containing x cubed from the given question here. So step 3, we continue with derivative. Okay, we differentiate step 1. Okay, so when we differentiate x with respect to theta, we will get dx over d theta. Alright, but over d theta from left hand side, we need to move to right hand side so that we get multiply by d theta. Okay, when we differentiate half sec theta with respect to theta, we still have constant half in front. And then from this formula, when we differentiate sec theta, the answer equals to sec theta tangent theta. So that's why we get this. right? So we get half. When we differentiate sec theta, we have sec theta tangent theta. And d theta here come from over d theta from left hand side, right? And after that, step 4, we need to eliminate the radical from the given question. From the given question, we have radical 4x squared minus 1, right? So, it is equals to square root of 4. We replace x squared from step 2, which is equals to half sec squared theta, and then minus 1. Okay, and after that, we can simplify 4 and 1 over 4 here. So, we get sec squared theta minus 1, right? And then we can write equals to square root of tangent squared theta. Okay, this comes from trigo identity. Okay, this formula and this formula actually the same. Okay, but this formula we write left hand side equals to 1 plus tangent squared theta. And this formula we move sec squared theta to left hand side. We write tangent squared theta as a subject and we move positive 1 to right hand side. So that's why we get minus 1 here. Okay. So from here we have tangent squared theta equals to sec squared theta minus 1. So that's why we get this. Okay. Tangent squared theta equals to sec squared theta minus 1. Right? And after that we can simplify square root of tangent squared theta, so we get tangent theta, right? Right, so from here, from the given radical function here, we have radical and no trigonometric function. But after we simplify using trigo identity, now we have no more radical but with trigonometric function, right? So in step 4, we successful eliminate radical from the given question, right? Right, after that, we substitute step 1, 2, 3, and 4 into the given question. Okay? So, therefore, from the given question, square root of 4x squared minus 1 over x dx, it is equals to square root integration of tangent theta over half sec theta times sec theta tangent theta d theta. Why we get this? Okay? We check one by one. Okay? We replace x equals to half sec theta from here. Okay? From step 1 here. And then we replace dx equals to half sec theta tangent theta d theta from here. Okay? And after that, we replace square root of 4x squared minus 1, which is equals to tangent theta from here. Right? Right. From the given question here, we are given in terms of variable x and with radical. After we substitute equation 1, 2, 3, and 4, now we have no more variable x and no more radical but with trigonometric function. Okay? And then we can simplify half sec theta and over half sec theta here. And then at the same time, we can multiply tangent theta and tangent theta. So after we simplify, so we get integration of tangent squared theta d theta. Alright, so from here, let's say we want to integrate from here. Okay, after we simplify. Alright, so we can check from appendix in final exam. Okay, from formula number 3 to number 7, these are integration of trigonometric function. So when we check from here, there is no formula for integration of tangent squared theta. Alright, but we have formula sec squared, integration of sec squared at x. So we recall back from integration by trigonometric function. Right, from this identity, okay, we can relate tangent squared theta with sec squared theta, right? So since from the list of formula in appendix, we have formula of sec squared theta. So we can write tangent squared theta equals to sec squared theta minus 1. Okay, from this formula. Okay, because from this formula, we have formula of integration sec squared ax dx. Right? And there is no formula for integration of tangent squared theta or tangent squared x. So that's why we need to relate with trigo identity. Right? So we can write sec squared theta equals to we can write tangent squared theta equals to sec squared theta minus 1. So that we get term containing sec squared theta. So we can use this formula to integrate. Right? And from formula number 5 here, let's say we replace a equals to 1. So we get integration of sec squared x dx over 1 over 1 equals to 1. No need to write. And then tangent x plus c. Right? So from here, we have variable x and dx. But now we have variable theta and d theta. Right? Alright, we recall back from the previous slide. After we use trigonometric substitution, we get the given question integration of square root of 4x squared minus 1 over x dx equals to integration of sec squared theta minus 1 d theta. Right? And to integrate this function, we can refer from integration formula from appendix, okay, in final exam. Now we look at formula number 5. Okay, we have integration of sec squared ax dx equals to 1 over a tangent ax plus c. And if we replace a equals to 1, we will get integration of sec squared 1a dx equals to 1 over 1, no need to write, tangent 1x plus c. Okay, so this is the formula in terms of variable x dx. Now we have in terms of variable theta and d theta. So from here, we can integrate with respect to theta. Okay, when we integrate sec squared theta d theta, from this formula, we get tangent theta. And then minus, and when we integrate 1 with respect to theta, we get theta. And then after we done integrate, we put plus c at the back. Right, because this is indefinite integral. Okay, so we must put plus c at the back. Okay. Alright, from here, we have successfully integrate. Okay. However, the original question was given in terms of variable x. And there was no trigonometric function. So, it is impossible to get the answers in terms of variable theta and trigonometric function. Okay. So, we not finish our solution. Okay, we still not finish yet our solution. So we can write as equation 1. Okay. So from here, we can replace theta by using triangle method. Okay. So when we use triangle method, we start with the first step from the previous slide. Okay. From the first step, we have x equals to half sec theta. So from here, we write sec theta as a subject. We move to denominator 2 to left-hand side here. So we get 2x. Okay. 2x means 2x over 1. Okay. And to draw a right angle triangle with sides. Okay. So we can write cos theta. Okay. Because sec theta is a reciprocal function for cos theta. So since sec theta is a reciprocal function for cos theta, we can exchange numerator and denominator from sec theta. So we get cos theta equals to 1 over 2x. Okay. So from cos theta equals to 1 over x here, we can draw a right angle triangle with angle theta. Okay, and then we put 1 in adjacent, we put 2x for hypotenuse, because cos theta means adjacent over hypotenuse, right? And then we can use Pythagoras theorem to find the third side. Okay, so using Pythagoras theorem, we have 2x squared, 2x bracket squared, and then minus 1 squared, which is equals to 4x squared minus 1 square root. Okay, so from here, when we compare from radical in the given question, okay, so we have same as the radical from this radical from opposite, from the length of opposite here, we have radical 4x squared minus 1, okay, which is same as the radical given in the question. So it means that our substitution from step 1, which is x equals to half sec theta, is correct, right? That's the way how we check whether we choose the correct formula for step 1, because step 1 is very important, right? Right, after that, now our goal is to replace tangent theta and theta into equation 1. So we need to find theta. So to find theta, we can write theta equals to, we move sec theta to right hand side, so we get inverse sec 2x. Or we can also write theta equals to inverse cos 1 over 2x. Okay, up to you to use theta equals to sec x, inverse sec 2x, or theta equals to inverse cos 1 over 2x. Okay, let's say we take theta from sec theta here. So we get theta equals to inverse sec 2x. Okay, and then from equation 1, we need to find tangent theta. So tangent theta means opposite over adjacent. Okay, so we can write tangent theta equals to square root of 4x squared minus 1 over 1, because our adjacent equals to 1. Okay, but we don't need to write over 1. Okay, and then we can substitute theta and tangent theta into equation 1. Okay, so from here we substitute tangent theta in theta into equation 1 here. So we get the original question, integration of square root of 4x squared minus 1 over x dx equals to tangent theta equals to square root of 4x squared minus 1 minus theta equals to inverse sec 2x, then plus c. Okay, we replace tangent theta equals to square root of 4x squared minus 1 from here, and we replace theta equals to inverse sec 2x from here, and then plus c. Okay, now from the given question here, we get the final answer in terms of variable x with radical. Okay, so now we done integrate. Okay, we finish our solution. Alright, got it? Alright, now we look at example 3, but with extra explanation. Okay, let's say I write example 3 now as example 3a. Okay, from example 3, we have integration of square root of 4x squared minus 1 over x dx. Let's say we want to use integration by u substitution. Okay, and when we use u substitution, let's say we take u equals to 4x squared minus 1, and then we need to differentiate. Okay, remember when we use u substitution, we have derivative part and integration part. In derivative part, we need to differentiate. Okay, so when we differentiate, so we have 8x, and then we write dx as a subject, so we have du over 8x. And after that, we replace back into the given question. So we have integration of square root of u. We replace 4x squared minus 1 equals to u, and then over x times, we replace dx equals to du over 8x, right? And from here, we have x in denominator and the second x also in denominator. So, in this case, we can't simplify, right? So, means that this is the wrong method. Okay, we cannot use u substitution to integrate this question because when we choose any function as u, we cannot simplify variable x. Okay? Alright, but how about, let's say, we modify example 3 here, and let's say we're naming it as 3b. Okay? We just exchange numerator and denominator. Okay? Let's say now the question is integration of x over square root of 4x squared minus 1 dx. Okay? And then let's say we use the same technique. Okay? Using integration by u substitution, we choose u equals to 4x squared minus 1, and then we differentiate. So we have 8x, and then we write dx as a subject. So we have du over 8x. So from here, we still have numerator x, and then square root of, we replace u equals to 4x squared minus 1, and then times, we replace dx equals to du over 8x. Okay, from here, we have x in numerator and x in denominator. So we can simplify. In this case, we can simplify. Okay, and after we simplify and we move constant 1 over 8 we move out from integration sign. So we have 1 over 8 integration of 1 over sec u du. And we can write 1 over 8 integration of u to the power of negative half du. Okay, we write 1 over sec u equals to u to the power of negative half using the properties of indices. Okay, alright, so from here, this is the correct method because we can simplify variable x and we successfully write u in terms of du and no more variable x. Okay, so this is the correct method, right? The difference between 3a and 3b, we just exchange numerator and denominator, right? And how about if we have 3c? Okay, we still use the same radical, which is 4 radical square root of 4x squared minus 1, but now we have x in front. Okay, and then dx here. Let's say we use the same technique. Okay, we use integration by u substitution. Okay, so when we use integration by u substitution, we have derivative part and integration part. So since we still have the same radical, which is square root of 4x squared minus 1, so we can write u equals to 4x squared minus 1, and then when we use u substitution, we need to differentiate, so we get 8x, and then we write dx as a subject, which is equals to du over 8x. So from here, we have integration of, we still have x in front, and then square root of, we replace 4x squared minus 1 equals to u, and we replace dx equals to du over 8x, right? And from here, we also can simplify x from numerator here and from denominator here. So, after we simplify and we move out constant 1 over 8 from integration sign, so we have 1 over 8 integration of square root of u du. And we can write equals to 1 over 8 integration of u to the power of half du. Okay, so from here, we also use the correct method because we can simplify all variable x and we successfully write in terms of u and du. Right, so 3b and 3c are the correct method when we use u substitution because we can simplify variable x and we successfully write all terms containing u and du only and no more variable x. So 3b and 3c we can use integration by u substitution. But for example 3, or we naming it as 3a just now, we cannot use u substitution because we cannot simplify variable x from the given question, right? If we want to use u substitution, we need to simplify the original variable and we need to write all in terms of u and du. But if we can't simplify, so maybe we choose the wrong method or maybe we choose wrong u, right? Now we look back 3b and 3c. Okay? From 3b and 3c, after we simplify, 3b we have u to the power of negative half and 3c we have u to the power of positive half. And from here, our n means the power is not equals to negative 1. So from here, we can integrate using power rule. Alright? You got it? Coming up next, more examples for integration by trigonometric substitution. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.